Before viewing video lessons, it is important to read the textbook using a learning guide as your turn-by-turn directions. Then, use the learning guide to take organized notes in your own words with examples and pictures. Chapter 2, Psychological Research. This video lesson will cover sample selection, data collection, analysis, and the reporting of findings. This is the scientific process. We are going to begin by talking about sample selection. In most research, it's impossible to study the entire population of interest. If, for example, I'm interested in college students, it would be impossible for me to do a survey with every single college student. So what we do is we select a sample from the overall population. The sample is ideally representative of this population. Once you have your sample selected, you will then move on to collecting the data. The type of data collection method varies by hypothesis, design, and practicality. We're going to discuss the different types of data collection based on design. In descriptive and correlational research, there are a number of different techniques that can be used. In descriptive research, you can do a case study. This is where you study just one single case. It is difficult to draw firm conclusions about the general population from one single case. In descriptive and correlational research, you can also do observational data collection. This is typically done in a natural setting. So, for example, if I was interested in how many people wash their hands after using the restroom, I could simply hang out in a public restroom and just take note of how many people wash their hands versus don't after using the restroom. Or I could do some correlational research where I can just observe in a natural setting some of those variables of interest. You can also do observation in an experiment, but this is typically done in a controlled or laboratory setting because in an experiment we need to have control over the variables. Both descriptive, correlational, and experimental can involve survey research. Surveys can be questionnaires, which are kind of paper and pencil questions, or they can be interviews, either face-to-face or via the phone. Both descriptive, correlational, and experimental can also have psychological tests. These could be tests of memory, tests of academic skills, tests of personality. There are several standardized psychological tests. Both descriptive, correlational, and experimental can involve physiological recordings. Physiological recordings involve recording some aspect of the person's physical functioning. In psychological research, we could measure heart rate, we could measure muscle tension, we could measure your stress level through how much sweat is on the surface of your skin. There's a variety of different physiological recordings. We could do different scans of the brain. The final way of collecting data in both descriptive, correlational, and experimental designs is to use archival records. Archival records means the data has already been collected and has been stored in some sort of archive. So for example, I could look at the correlation between your grades in college and your grades in high school. Those grades would be in your transcript for college and your transcript from high school. I wouldn't be generating new information I would just use the old records. Finally, the internet has provided a new way to collect all different types of data for both descriptive, correlational, and experimental research. This presents new challenges to ensure that the data is of good quality, that the person who is completing the measure is who they say they are. But it also opens up some doors in terms of having a more representative population or representative sample based on the population. For example, most of our research is done on college students because they're convenient for researchers who work at universities to find. But college students aren't a perfect representation of the entire population. Once there is data that's been collected, it will be analyzed with the various statistics, descriptive statistics for descriptive designs, correlational coefficient for correlational designs, and inferential statistics for experimental designs. While analyzing the data and drawing conclusions, we're going to be looking at flaws that are in research. It's important to use statistics to determine our findings versus just sort of giving it an eyeball, general feel, this is kind of how it looks. Once we have those statistics, the strength of the conclusion is going to be related to the hypothesis. We need to determine if our hypothesis was supported or refuted, or we right or wrong in our prediction. Of course, the statistics themselves, also how much control over variables if it's an experimental design, and research flaws. All research is flawed in some way. There has never been a perfect research study without flaw. One type of flaw common in all research is sampling bias. This is when the sample that is selected is not a good representation of the entire population. If, for example, I wanted to say something about all college students, but my sample came only from students at Jefferson College, I would have a flawed sample because the students at Jefferson College aren't a perfect representation of the entire population. The other problem with somewhat related to sampling bias is something called anecdotal evidence. This is when you try to draw conclusions from a single case. So for example, if you find out that your hairdresser's cousin's babysitter's dog walker had something happen to them, does that mean that that's the norm for everybody? Probably not. Also, that story is maybe not entirely accurate by the time it gets to you. Another type of research flaw that's common in survey research with questionnaires or interviews are distortions in self-report data. One distortion is called social desirability bias, and this is our tendency to try to kind of fudge our answers in the direction of making ourselves look just a little bit better. So for example, if I asked you how many times a day you flossed, you would probably tell me that you flossed slightly more than you really do. Now this is not exactly intentionally lying. Chances are you intend to floss and you know you should floss more than you do. And so when I ask the question, you tell me what you're hoping to be versus what you really are. In the case of long questionnaires with many questions, one of the things we find is that participants will sometimes get into what's called a response set. So imagine answering over 500 true-false questions. After a while, You might kind of just get stuck in a rut of, I've answered the last 5 false, so I'm kind of in a false, 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 and not necessarily reading the questions carefully. In experimental designs, you can have several specific types of flaws. These include lack of control over every variable in the study, and the lack of random assignment if you're trying to do a true experiment. Another flaw in experimental research is something called the placebo effect. In the placebo effect, what we have found is when a participant has the expectation that something's going to change based on something done, a drug taken, video watched, a test done, whatever the study is set up to be, then we find that that has an effect all by itself. So in the case of the morphine study, where one group got morphine and one got a placebo, what we would find is both groups actually report feeling better. If morphine really works, the morphine group would have felt significantly better than the placebo group. That's the placebo effect. The last of our research flaws is experimenter bias. So if, for example, I'm doing a study to test morphine to see if it helps with pain, and half of the group gets the drug, the experimental group, and half of the sample does not, the control group, and then I interview them afterwards to find out how they're feeling, and I know which group got the drug and which didn't, I'm likely to treat them differently. For example, the morphine group, I may say something like, "Oh, how are you feeling? Aren't you feeling so much better?" And in the group that I know did not get any drugs whatsoever, just the placebo, I may say something like, "All right, how much does it hurt? Sucks, doesn't it?" So what I might end up doing inadvertently is actually treating the groups differently, in which case I can't say it's really the drug that had an effect. It may be the way I treated them. The way that we get around this is with the double-blind solution. In the double-blind solution, the participants don't know if they got the real drug or not, and the research assistants that come in direct contact with them don't know either. So whoever interviews the subjects after they take the medications should be somebody who doesn't know who got what. The final step in the research process is reporting the findings. Science is a process. Science only progresses when research is shared, and typically this is shared through publication in a scholarly journal or presentation at a scientific conference. Most science also goes through a peer review process. This process helps to maintain the scientific standards. So you are unlikely to read an article in a peer-reviewed scholarly journal that did not adhere to scientific standards. Science is dead without the reporting of research and the use of that research in informing new studies. So if we don't have reports, then what we'll end up doing is constantly reinventing the wheel over time. What we want to do in science is not keep reinventing the wheel, but take the previous research and improve on it so that the wheel improves over time. Psychological research published in scholarly peer-reviewed articles is written using the formal rules of APA style. You will see an abstract at the beginning, a small summary, followed by a review of the literature or their education about their hypothesis, then their hypothesis, followed by methods, results, and discussion.